Hello Math 10 and welcome back. Today we are going to look at surface area and volume of pyramids and cones, okay? So just to start off, I want you to think about how are cones and pyramids similar? And how are they different? And jot down some ideas, how they're similar, how they're different, okay? Once you jot down those ideas, I want you to come back to the video. So pause, jot down those ideas, should just be one or two things, or more if you could think of, then come back to the video. Okay, so now we're going to look at the volume of a pyramid. And the volume of a pyramid is very strongly related to that of a prism, okay, with the same base shape. I have a video here to show you exactly how that works. So just watch the video slightly. So if we notice, the base of the shapes are the same. They're both a square. They both have the same heights. The pyramid and the cube have the same heights as we put them back down together. Now if you remember, volume is how much it holds or how much it could displace. And there we go. So if we look at it, all the triangles are the same size, and the squares are the same size, or the cube. Okay? So basically, by looking at this video, we could see that three pyramids with the same base as the prism, okay, they have the same base, is going to be the same volume. So if they have the same height, same base as the prism, it takes three of the pyramids to make the volume of the prism. Alright? Now, there we go. We just kind of answer that question. Now, the next one here is, what about a cone? Okay? What is a cone shape related to? What kind of prism is a cone shape related to? Starts with a C as well. Okay? Now, can you figure out the volume of a cone? Think of last time before. What would have to be the base shape of the cone? What is the base of the cone? Okay? I want you to think of that one. What is the base of the cone? And come back. So now that you've jotted down what is important for volume of a cone and what you think is important, which measurements in this shape here do you think is important for a cone? Well, I'm going to highlight the ones here for you. So I'm going to say height is important, and my radius is going to be important, because the radius will help us find what? The radius will help us find the area, okay? Which will help us find the area there, right? So we find the area of this circle, then we multiply it by the height, okay? That will give us our volume of a cylinder. But now we know a cone is kind of like a pyramid. It's the pyramid of cylinders. Now the cone is going to be 1/3 the volume of a cylinder. So I go pi r squared. Okay, so I'm just going to have to go here. Here we go. Volume is equal to, we're going to go 1/3. And we have pi r squared. Oops. And we have a little 2 there, multiplied by the height. Okay, so it's 1/3 of the volume of a cylinder, right? Now, so now we're going to look at how to find the total surface area of a cone. I look at this here. These are my two shapes. This is the net of a cone. These are my two shapes. I have this curved surface and a circle. Now my hint is, my problem is, we have to try and find the area of this curved face. Now, how do I do that? Well, I know that this part here is the same distance as a circle, right? That is the circumference of the circle. So that this part here is equal to 2 pi r. All right? So I'm just going to go to this right here on my sheet. So I know that this part here is equal to 2 pi r. Now this is kind of like a triangle, except my bottom part is 2 pi r. Okay? So what is the area of a triangle? It's base times height divided by 2. But my base here is equal to 2 pi r. So it's going to be base, which is, 2 pi r, right? Because these are the same. So I'm going to have 2 pi r multiplied by my height. In this case, we're going to say the slant, because my height will be right here. I'll say that, which is my slant, multiplied by the slant. And we're going to divide that by 2. Okay? Because that's going to be actually this value here, this slant, right? No matter what, it's always the same. And we divide it by 2. So I get pi rs is equal to the area of this shape. So it's going to be pi rs multiplied by the area of a circle, which is pi r squared. Added to the area of a circle. So that is my total surface area. Pi rs multiplied plus pi r squared. Area of a circle plus the curve shape. Okay? Now, here we have our first question. The Great Pyramid of Giza is approximately 147 meters tall and has a square base with sides measuring 440 meters. Make a sketch of the pyramid and calculate the volume to the nearest cubic meter. Okay? So we want to calculate the volume to the nearest cubic meter, but first make the sketch. So my sketch, we have a square base like that, and it's going to kind of look something like this, right? This is 440 meters, and we have a slant height of, it's 140 tall, so from here to here it's going to be 147 meters tall, and square base, sides measuring 440. So there's my sketch. Now we want to find the volume to the nearest cubic meter. Well, if we remember, this is like a square or prism, right? It's like a square prism. So we have a square face and it's 147 meters deep. But it is a pyramid, so it's going to be 1/3 of that volume. So we have 1/3 multiplied by my base times height multiplied by my depth. So I have 440. This is going to be 440 meters as well. So I have 1/3 multiplied by 440, all multiplied by 147. And we only are going to be 1/3 of that is going to be the volume from the video that we saw earlier. So I'm going to end up getting, when I do this, a total of 9,486,400 meters cubed. And that is my volume. Okay? So my next question here wants me to find the total surface area of the pyramid. Now, basically, to start this off, we must first draw a net, okay, to see what we're looking with. So here's my net. Look at that. We have a square base, goes up with triangles. Whoop, make this a bit nicer. Triangles. And we have another triangle here and another triangle there, right? Now, I know this base is 440. But now, we need to know this height of the triangle, right? This little height going up. What is that height? That's not going to be the height of this, because this whole thing is 147, if we look, right? And now, we want to know what this slant height here is, the actual slant height. Another view would be, if I looked, this is the face, right? That's the face. We're trying to actually find this slant height straight up and down. This is 440, and this here is 120 or 147, right? So we have 440, 147. So in this part here is really going to be 220. So we have a triangle that looks like this. This is my slant height, which would be that height, okay, which is going to be my slant height. We have my height here, which is 147, and I have 220 is that part there. So in order to find the area of those triangles, we must first find my slant height. So I'm going to have to use Pythagorean Theorem. this is going to be right angle, which is going to be c squared is equal to a squared plus b squared. Okay? Now I'm going to end up getting 147 squared plus 220 squared. Okay? And if I continue that, that's going to give me the square 7,000 or 70,000 and 9. Okay? And we have that as in meters squared. Meters. Now, what I have to do is, this is c squared, so c is equal to the square root of meters. Okay? There we go. Done. So now I know this height here is that, right? That is my S. Okay? So let's now find my area. So my area, or my volume, or sorry, my area, my total surface area. My area is equal to, we have 4 triangles. Now we don't use the bottom because that one's like the center, it's the base. So what we see are these 4 sides, right? So that's going to be my total surface area. Is equal to, there's 4 of them that are identical, so it's 4 base times height divided by 2, which is the same thing as 2 base times height. Okay? Now I look at this height. These heights are actually this S. This is my height of the triangle. So it's really base times side, you might say, or slant. Okay? So now we have base, so we have 2 multiplied by 400, multiplied by my height, which is going to be the square root of 7009. And we're just going to plug that into my calculator, and I'm going to end up getting 232,841 meters squared. And that is going to be my area. Okay? And that's it. Okay, so now we have a cone-shaped object with a height of 15 centimeters and a base diameter of 16. So it wants us to determine the volume and surface area of the cone to 1 decimal place. So we draw this out. I'm going to have a cone that looks like this, right? Now we know my height is 16, or 15, right? Height is 15, and my diameter is 16. Okay? Now looking at this, my net is going to look something like this. And there's my circle. Okay? Now in order to do this, to find the area, we need to know this slant height, if you remember from our formula. Now, I know my height here is 15, but I do not know this slant height right there. Okay? Now, I know this part here is going to be 8. So now I have a right angle triangle that looks kind of like this. So this is 8, this is going to be 15, and this is my slant. How do I find that? I am once again going to have to use the Pythagorean Theorem, which is c squared is equal to a squared plus b squared. In this case, c is s, so I have s squared is equal to 15 squared plus 8 squared. Okay? I continue this, I'm going to end up getting 289 is equal to s squared. Square root both sides, I get 17 centimeters is equal to s. So now I know my slant height. Now I can find the area of this here. Okay? So if you remember, my total surface area is going to be pi r squared plus pi r s, the slant height. Okay? My radius is 8. It's half the diameter. So we have pi 8 squared plus pi 8 multiplied by 17 is my slant height. Okay? And I can put this into my calculator now. I'm going to end up getting 628.3 centimeters squared. Now let's find my volume. Okay, so we did my surface area, so now we're going to do my volume. My volume is equal to my base area, so we have pi r squared multiplied by the height. And then we must divide it by 3, because that would make a cone if we did it. A little cone like that. So we must divide it by 3, a cylinder, because a cone is 1/3 the volume of a cylinder, like we saw from the videos. So now we divide that by 3, and I'm going to end up getting pi multiplied by my radius, which is 8, squared, multiplied by my height, which is 15, and then we have to divide that by 3, and this is going to end up giving me a total of 10,000 or 1,005. 0.3 centimeters cubed. Let's take a look at our last question here. It says, a right pyramid has a height of 20 centimeters and a hexagonal base with sides measuring 10 centimeters. So it wants us to make a sketch and find the area to an exact value to the nearest centimeter. Okay, so here's my hexagon, which is a 6-sided shape, kind of looks like a stop sign. Okay, it's a regular hexagon. Now, I'm going to just do this here. Now, if we notice, a regular hexagon is made up of 6 triangles. Okay? Now, the interior here is a circle, right? If it's a circle, each of these here are going to be 60. Okay? Because 360 divided by 6 is equal to 60. So each of these angles are 60. These are going to be the same, and, well, if those are the same, then basically this angle and this angle must be the same, which means they must be 60 each. So this is made up of 6 equilateral triangles. Okay? Now, if I know these are equilateral triangles, this could help a bit, because we will have to find the height of each triangle. So here's one triangle. We have that. I know this here is 10, because each side is going to be 10, so 5 and 5. Right? Now we're trying to find the height, or this here. Okay? So we're going to just look at this triangle right here, where it's 5 and 10. So let's do that, because that will help us solve for the area of my base. So we're going to have c squared is equal to a squared plus b squared. In this case, we're trying to find one of the legs, so a. So I have a squared is equal to c squared minus b squared. Okay? I'm going to continue this. I'm going to have a squared is equal to 10 squared minus 5 squared, which is going to give me 75, and we want the square root of that. All right? Which is the same as 5 root 3 centimeters. So this is kind of going back to our very first unit. All right? So that is my height of each triangle. Now that I know that, I could find the area of one triangle, or the area of, and there's 6 triangles, so I have to multiply that by 6. So my area of a hexagon, just make a little hexagon shape there, is equal to 6 multiplied by base times height divided by 2. So it's 3 multiplied by base times height. Well, my base is going to be 10, and my height is 5 root 3. So that's going to be 10 multiplied by 5 root 3, which will end up giving me, we're going to get 150 root 3. Okay? So that's going to give me 150 root 3. Now, right there, this will give me my total for each of these here. That will give me my total area. Okay? Now, we know it has a height of 20 centimeters, though. Determine the area. So we just want the hexagonal base and the area of that. So it's 150 root 3 centimeters squared. That is my area. If I wanted to find the area of the total surface area, that's a bit different. Then I have to look at my other triangles and add those up. Okay? Now, part B says the pyramid is filled with water. Determine the volume of the water to the nearest milliliter. So now we want to determine the volume. So my volume is equal to my base area. So that's the area of the hexagon multiplied by its height. Okay? Well, what is the area of the hexagon? I said 150 root 3. 150 root 3 centimeters squared. And we have to multiply it by the height, which it says up here is 20 centimeters. Which is going to end up giving me a total of, this is going to give me 3,000 root 3 centimeters cubed. and that is my volume. Okay? And that's, oh, but now, this is for if it was a hexagonal prism. What must I do is I also must divide by 3, and divide this by 3, and divide this by 3. Why? Because it is a pyramid. So I have 1,000 cube root of 3 centimeters cubed. You get that? Because this was for a hexagonal pyramid, so then I had to divide by 3 because it is a pyramid. So hopefully you understood everything. Good luck as I see you tomorrow.